about polynomial equations. We're going to be looking at some higher order, higher degree equations and looking at ways that we can solve them, how we can find their roots or x-intercepts. Last unit, when we were looking at polynomial functions, and we specifically looked at them in factored form, we realized that we can identify the zeros of the function, the x-intercepts of the function, just by looking at the factors, and that helped us to graph the higher order, higher degree polynomial functions. So in a polynomial, we can find the roots by letting the function equal 0 and then solving the function, solving p of x equals 0. If we have a polynomial that is factorable, if we can factor it, then the values of the roots can be determined algebraically by solving each of the factors. As well, if we have a polynomial that's equal to 0, we can also solve it graphically by looking at the x-intercepts of the function. We did a little bit of that last unit. Now we're going to do a little bit more. We're going to go a little bit further. So let's look at two examples where we have polynomial equations that are of degree 3. So these are cubic equations. And we're being asked to solve them by factoring. So if I take a look at part A, I should be able to identify in part A that there's a common factor that I can pull out right away. There's a common factor of x that I can factor out of all my terms right off the bat. So if I pull out a factor of x, I'm left with x squared minus x minus 2. And then I should be able to recognize that I could then continue to factor this quadratic using simple trinomial factoring. So I'm looking for two numbers that multiply to negative 2 and add to negative 1, and I think those two numbers are negative 2 and positive 1. So we started by factoring out x first. Then we factored the trinomial. And then we can summarize by saying that the solutions to this polynomial are x equals 0, x equals positive 2, and x equals negative 1. In part B, question B, if we look at this the way we were looking at polynomials yesterday, we would use the integral 0 theorem to find factors of 4, and we'd use those factors of 4 to test in our x values, in our variables, to see if that made the polynomial equal to 0. And we can do that, and we can get the right answer. But if we're clever, we should be able to see a shortcut in this polynomial. I could try and factor by grouping, by pulling out a common factor in the first two terms and the common factor in the last two terms. So in the first two terms, I notice that I have a common factor of x squared. That leaves me with 3x plus 1. And in the last two terms, I have a common factor of negative 4. And that leaves me with 3x plus 1. And that equals 0. And we know that this factoring by grouping works because when I pull out those common factors from the first two and the last two terms, what I have in the brackets are equal to each other. So that gives me my first factor, factor of 3x plus 1. And then my second factor is x squared minus 4, and I should again recognize that I can factor that using difference of squares. factor of x plus 2, a factor of x minus 2. That equals 0. And again, therefore statement, my solutions to this polynomial are x equals negative 2, x equals positive 2, and x equals negative 1/3. So it's helpful for us to try and find some shortcuts. Okay, in the first example, we were able to pull out that common factor, which meant we didn't have to do any polynomial long division. In the second example, we were able to factor by grouping, again, avoiding polynomial long division. But that's not always going to be the case. In example 2, looking at the polynomial, there's no common factors that I can pull out. If I try and factor by grouping, I don't think I'm going to end up with the same common factors, so that's not going to work. So I need to factor this using polynomial long division. So I need to find some values to test. So I'm going to look for factors of 6 divided by all the factors of 2. I think that'll give me a list of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then my fractional factors plus or minus 1/2, and plus or minus 3/2. So these are the factors that I'll test in the polynomial to see if I can get it to equal 0. You can try those on your own, but I'm going to claim that 2 is a 0, which means that x minus 2 is the factor that I'm going to divide by. So I showed you synthetic division yesterday. I encourage you to use that for your problem solving. Write the coefficients. And we start to divide. So 3 take away negative 4 becomes 3 plus 4, so we get 7. 7 times negative 2 is negative 14. Negative 11 take away negative 14 is positive 3. So by doing one step of my division, I end up with a factor of x minus 2 and a second factor of 2x squared plus 7x plus 3. And this is equal to 0 since we're trying to solve. I could try and do polynomial division again, but I don't really need to. I have a quadratic as my second factor. So I can factor this, and I would be factoring this using decomposition. So two numbers that multiply to 6 and add to 7. I think those two numbers are 6 and 1. So I decompose, I break apart the middle term into a term of 6x and a term of x. And then I pull out some common factors in the first two terms. Try and pull out a common factor in the last two terms, but the only common factor is 1. And then finally, I end up with up with three factors. So I can say that x equals 2, x equals negative 3, and x equals negative 1/2. So just to summarize, we'll go a little bit further tomorrow in class, but the roots of a polynomial equation are just equivalent to, they correspond to the x-intercepts of the graph. And if we can factor a polynomial equation, then we can set the polynomial equal to 0, do our factoring either by grouping or by our polynomial long division. We set the factors equal to 0, and then we solve each factor individually. Later on, we're going to look at what we can do if we can't factor a polynomial. We'll be using the TI-83s to determine the roots of our graph using those calculators. So in class tomorrow, we're going to be working on these questions. If you'd like to get started ahead of time, by all means do. Thanks for watching.